Hello everyone! Today we're going to explore an interesting and efficient algorithm known as exponential search. You might be familiar with binary search, which is a powerful way to find elements in a sorted array, but what if you're dealing with a massive dataset or even one where the size isn't known upfront? So that's where exponential search comes in. Well, it's designed for sorted arrays and it combines a clever range detection step with the precision of binary search. The goal is to locate our target element as quickly as possible, even the array is large or unbounded. And in this presentation, we'll walk you through how exponential search works, when to use it, and why it can be a smarter choice than binary search done in a certain situation. So, what exactly is exponential search? Well, it's a method used to find the position of an element in a sorted array. First is, it quickly finds the range where the element might exist by doubling the index, and then it applies binary search with that range. And it also makes it much faster in scenarios where we don't know the array size. So why not just use binary search? Well, binary search requires us to know both ends of the array. If we don't, or if the array is very large, exponential search helps by quickly locating a potential range before using binary search. And it's also ideal for sorted and potentially unbounded arrays. So here how it works. So first, we start from index 1 and double it, checking index 1, 2, 4, 8, and so on, until we either go out of bounds or find a value greater than or equal to the target. Then we perform a standard binary search between the last valid index and the current one. So it's very fast and efficient. Since we're done talking about how it works, so let's look at its performance. So the total time complexity is order log I, is a logarithmic in the position of the target element. So this makes it very efficient, especially if the element is near the beginning. And since it uses no extra space, it has a space complexity of order of 1.
We're going to talk about how this algorithm is going to be useful in our real-life situations. So exponential search is a searching algorithm used when we are looking for an item in a sorted list, but we don't know where the item is located. And it's more efficient than checking one by one, especially for long lists. So let's imagine this. You have a printed phone book, and it's arranged in alphabetical order. You need to look for a person with the last name Mendoza. So instead of turning the pages one by one, exponential search works like this. So you have to start at the first page, then jump into page 2, then 4, then 8, then 16, then 32, and so on and so forth. It's like we double the number, the page of the number. Once we jump to a page where the name is past Mendoza, let's say we reach page 64, and C name starts with N, we know that Mendoza must be between pages 32 and 64. From there, we use binary search in the smaller section, pages 32 to 64, to find the exact page with the same name, Mendoza. So this method is very efficient because instead of checking every page, we quickly narrow down the search area, then find the exact match. It's an efficient method for searching large, sorted lists without knowing the exact position of an item. It saves time by expanding the search range and using binary search within smaller sections. This approach is useful in real-life situations like phone book searches, digital search, lists, and big data management. Understanding exponential search helps appreciate how algorithms make searching faster and more effective in everyday tools and technologies.
In this video, we will see what is exponential search and how to apply exponential search on an array in order to find an element present in that array. If you have not yet subscribed to our channel, then please do so in order to watch more of these programming videos. So let us get started. Let us take an example in order to understand how to to apply exponential search, by the way, the prerequisites of exponential search is that the array should be sorted. So I have taken an array containing 12 elements which is arranged in ascending order. And let us say we want to find 11. So let us define x equals to 11. And we want to find this element x if it is present in the array or not. What we will do is we will start from the 0th element. We will first compare this 0th element and is a at 0 equals to 11. No, it is not equals to because it is 1. So what we will do is now we will take a variable I. We will take a variable I and we will start from 1. So let us take a variable I. Let me change the color and it will start from this one, index 1. That is a at 1 is 2. Now we will write our code. So our code will be something like this. We will take a while loop while we will compare I with all these elements. While I less than n is the number of elements. And here we have 12 elements, so n will be equal to 12, and a at I should be less than equals to x. So the elements we want to find is x. Now we will increment this I value by multiplying it with 2, and let us see how it works. Oh, we are comparing it with this one, i's value is initially equals to 1 because we are starting from index 1. Now, I is less than n because n is 12. So, it has not crossed the boundary of this array. And this second condition is saying that a at I is less than equals to x. The element to be found. Yes, 2 is less than. So both these conditions are true. So I will become 2 because I times 2 is 2. Now again, while loop will run and we will move to this second element, the element at index 2. Now we can see that this value I 2 is less than n, so this is true, and a at I, that is 3, is less than equals to this 11, so this is also true. Therefore, we will increment this I and this will become 2 times 2, which will be equals to 4. So now we will move to 4. What we will do is we will see if the index is out of bounds or not. This first condition is for out of bounds checking. So 4 is less than 12, so it is not out of bounds. And a at I, that is 5 is less than equals to x. It is true. Therefore, we will update I, so I will become 4 times 2, which will be 8. Now, we will move to index 8. Now, i's value is 8. So, I is still in bounds. So, this is true because 8 is less than 12. And a at I, which is 10, is less than equals to 11. So, this is also true. And therefore, we will increment this I from 8 to 16. So, I will be pointing to somewhere here. And this is clearly out of bounds, so it will be pointing to index 16, which is out of bounds. It is not present in our array. Now, as soon as we check, this is I less than n, so this comes out to be false. And so the while loop breaks. Now, your i's value is 16. And you want to find this 11. Now, we will do is, we will apply binary search. We will call binary search. And the array is A. The low value will be this I divided by 2. Low value will be equals to I divided by 2. And I divided by 2 is 8. So, low value will be I divided by 2. High value will be minimum of I and minus 1. Why are we applying this minimum of I and minus 1? Because we cannot do binary search on the array if it is out of bounds. So, we just want to consider these 4 elements instead of taking the elements from index 8 to index 16. Because element elements beyond index 11 is not present. Therefore, we will take from I divided by 2 to minimum of I and minus 1. And why we are taking minimum? There might be a case where, let us say, the array size is 20 and our I's value is 16.
We will do this binary search from index 8 to 16. Since the array is larger, so we will take the minimum size of the array because we want to minimize computation and also we don't want to cross the boundary of the array. And then we have taken the array, the lower bound, and then finally we will give the element to be searched. And this will perform the search on the given sub-array in order of log and time. Now what will happen is we have this array, we have this entire array 9, 10, 11, and 12, and the corresponding indices will be 8, 9, 10, and 11. Now what will be done is we will find the middle element, and mid will be 8 plus 11, and that means low plus high by 2, which will be equals to 9. So we will move this element, this 10, and this 10 is not equals to 11, and 10 is less than 11. So we will partition this entire array into 2 parts, and we will search for 11 in the right hand side. Now we will again find the middle element, and this time low will be equals to 10 and high is equals to 11, and this will be 10 plus 11 divided by 2, which will be equals to 10. So now we will check with 11, and you can see that we have found our element because we were searching for 11 and we found 11. So this is how exponential search works. Why the name is given as exponential? Because the value of I, which we are using in order to indicate the boundary for the sub-array in which the element has to be searched, is increasing exponentially. You can see that here I's value was initially 1, which can be taken as 2 to the power 0. Then I's value increased 2 to the power of 1, then it got to 2 to the power of 2, then 2 to the power of 3, then 2 to the power of 4. You can see that I's value is increasing exponentially. It is increasing in the order of 2 power n. So this increment is exponential. And this increment is done in order to find the sub-array in which the element to be found will be present. In this case, we were finding the sub-array in which 11 will be present, and we found that 11, if it is present in the array, then it will be present in the index range of 8 to 11. And this was the prime goal of increasing the value of I exponentially. So we can quickly find the sub-array, and then what we will do is we will apply binary search on the sub-array. Alright, now let us look at the time complexity of exponential search. You know that time complexity will be equal to order of log n because exponential increment is done very quickly, and here only the bottleneck is the binary search because this will take the longest time. Therefore, the time complexity will be order of log n. And what will be the space complexity? The space complexity will be order of 1. If we use the iterative version of binary search, and if we use the recursive version, if you use recursive binary search, then it will take order of log n extra space. So it is better to use iterative binary search. Let us look at some of the applications. So exponential search has some applications. And first application is it is useful for unbounded arrays. Now what does this unbounded array mean? Unbounded array basically means an array of infinite size. If you have a very large size of array, then in that case, you can apply exponential search and it will work quite well. The second point is that it works better than binary search. And how does it work better than binary search? When the element to be searched is quite close to the first element, then it will perform way better than binary search.
Let's say you have an array, okay, and let us say you have element 0, 1, 2. Let us say you have 5 key elements, and let us say the numbers are 1, 2, 3, and so on to 5 key plus 1, okay. So these are the numbers. Now let us say we want to find 2. We want to find element 2. If we apply binary search, then this entire array will be divided into 2 parts, and the 5 key divided by 2, the element will be seen first. And then we will see that this element is greater than 2. And so the left sub-array will be taken. And again, this will be divided into 2 parts. And again, 5 key divided by the fourth element will be taken. And so on and so forth. So it will take log n time, okay? And since n is very large, therefore log n will also be quite considerably large. Now you know that you are finding just 2. If you take exponential search, okay, then this first element will not match. Now when you start your I variable from this one, then it will have a sub-array size of only 1, and it will have only 1 element. So you will find these 2 in just 2 steps. Even if you search for, let us say you are searching for element 4, then what will happen is this I will not take care of it, and then this will increase to this 3, because 1 multiplied by 2 will be 2, and now this will also be less than 4, so it will increment to index 4. This 4 is at index 3, okay? So this at index 4 you will have something, let's say 5. And now what will happen is, since this 5 is greater than 4, so it will take the sub-array 3, 4, and 5. And now you can easily find 4. So in this way, if the element is very close to the starting position, then exponential search will perform way better than binary search. Therefore, you can see that exponential search is better than binary search. So this is all about exponential search. If you have any type of query, then do comment below and we will try to help you as soon as possible. The code for this exponential search will be posted in the description section, so do check it out. And if this video was helpful, then please hit the like button and subscribe to our channel in order to watch more of this programming video.